Hello, welcome everyone. Thank you to coming to the security and management session. The title of my talk is an analysis of applying stir shaken to prevent robocalls. My name is James Yu. I'm from DePaul University in Chicago. Okay. So this is the problem statement. This is the problem statement of my talk. So basically, we have so many robocalls, and that have caused billions of losses to the victims in 2019. And this diagram shows what is a robocall. So from the diagram, you can see a hacker that can use a computer to generate many calls, and those telephone calls will passing through the internet and or PSTN to the victim's telephone. And when the user responds to the telephone, and then this call can create a different scenario, and the hacker can also impersonate as a policeman or government agent, and that will cause the illusion on the victims, and which may cause the monetary loss. Okay, so that's the problem we have. And because of this problem, the law enforcement and U.S. Congress, they have tried very hard to prevent this problem. And the Federal Communication Commission, FCC, they have worked on this problem for quite a long time. And the U.S. Congress, they also established a telephone robocall abuse criminal enforcement and defense act, and this becomes law at the end of 2019. And the FCC follow up with the law, and they have a mandate that all telephone companies, they have to implement the caller ID authentication by June 30, 2021, which would be less than a year from now. So the major issues we are looking at is about the core authentication or caller ID authentication. So when you receive a call, what shows on your screen may not be the real person. And from these two examples, so on the left is my iPhone, on the right is a soft phone, okay, it's a computer soft phone. So in either case, you can see it's very easy to impersonate any ID as the caller ID on the receiver's telephone, and that's the problem. That's a problem of a lack of caller ID authentication in today's scenario. And this problem is primarily due to the voice over IP, and which become very popular in the recent years. And this is an example shows that a hacker can use a tool. The tool we are using in the lab called the SIPP. And from this tool, and this is basically an XML file. And you can see the hackers can fake the ID, the from. Okay, that's the caller ID that can be displayed on the receiver's telephone. And hackers can basically put anything on the from field, or actually hackers can put basically anything for any of those fields. So a lack of the caller ID authentication is the major problem of the robocalls. So how do we address this issue? So we have to look at the voice over IP standard. The voice over IP standard is called the SIP, Session Initiation Protocol. So the first protocol was specified in 2002, and this diagram shows the call flow diagram, and the message with a yellow mark is the messages with a yellow highlighted with yellow are the messages that can be authenticated. Okay, so however, this authentication is just a one-way authentication, and so it's from the server to authenticate the client, and also it's just for the client. Okay, so it does not authenticate the server. So that's the major issue with the original SIP authentication. And there have been a lot of the improvement to to improve the caller ID authentication. And in just about the same year, in 2002, and we have another standard that will create the caller ID in the SIP message. So the invite message, which is the first message of the SIP, that will include the caller ID. However, there's no way we can verify this caller ID in those in the original protocol. So over the years, there have been many attempts to make this caller ID security better. And so the most recent one is called STIR, S-T-I-R, stand for Secure Telephony Identity Revision. So the basic concept of the STIR is to encrypt the caller ID, and the encryption can be certified and verified by the security body. So as the caller ID, okay, so previously we have this caller ID, okay, identity, and this ID can be encrypted and can also be verified from one service provider to the next service provider. And it should also be noticed that the STIR is not just one RFC document. There are multiple RFC documents for STIR. So along with the STIR, there's a further step to create a testation. Testation is basically to assign the caller ID, whether this caller ID has been authenticated or not. Okay, so it's including both the caller ID and also the telephone number. Okay, so this mechanism will allow the receiver to check whether the caller ID and the phone number has been authenticated or not. So attestation is attached to the SIP messages and will be passed from one service provider to the next. And it should also be, it is also important to notice that the service provider, they are not going to filter the calls. The service provider, they will simply authenticate the caller ID, and based on the authentication, they will assign an attestation. It will be up to the end users whether to accept or reject the call based on the attestation. So this is the overall mechanism of the stir and the shaken that are required, that are mandated by the FCC for the caller ID authentication. So the purpose of this talk and this paper is to see whether this is an effective mechanism for caller ID authentication, and with which we can prevent the robocalls. So that's the major purpose of this talk, whether we can use this method to effectively prevent the robocalls. So from what we have discussed, I think we can generally agree that if we are on the IP network, if everyone uses the SIP, then this seems to be an effective method. However, we have to look at from end to end. It's not just from the service provider to the user, it's also between the service provider. And to discuss this mechanism, we have to understand UNI and NNI. UNI stands for user to network interface, and NNI stands for network to network interface. So basically, UNI is the interface between a service provider and its customer, and the NNI is the interface between the service providers. When we say interface, actually this is a legacy terminology. It really means the protocol, the standard between the two parties. Okay, so UNI is about the protocol between the service provider and its customer. NNI is about the protocols between the service providers. So with that, we have to ask a very fundamental question. So for the voice over IP, we are using SIP, Session Initiation Protocol. Is this protocol for UNI or for NNI or for both? The simple answer is UNI. So SIP is designed as a UNI protocol. SIP is not designed for NNI. Okay, there's a lot of the implication about the uni versus NNI. We will not get into. We will just give you the result that the SIP is for uni, not for NNI. So with that, we can see there is a fundamental problem of the star shaken, because the star and shaken is associated with the SIP, and the SIP is for uni. And what about the interface between the service providers? Can we use the SIP? Can we use the stir and the shaken between the service providers? The simple answer is yes, but there's a lot of the implication for that, and that will be the focus of our discussion here. So when we look at the two service providers, we also need to ask question, is those a peer agreement? So between the top tier service providers, they have the peering agreement. Between a top tier service provider and the lower tier service provider, and then it is really a uni, not an NNI. Okay, so this slide is very important. Okay, so between the top tier and the lower tier, it's really a provider and customer relation, even if they are both service providers. And for the top tiers, then that is the NNI. So when we want to look at the NNI between the service providers, between the top tier service provider, there are only two solutions, either PSTN or IMS. So it's very important to know that SIP is not in this picture here. SIP is between the top tier provider and the lower tier provider. And the SIP cannot be used or is not used between the top tier providers. So now the question is that, can we apply the SIP and can we apply the stir and shaken in the between the top tier providers? Okay, so first we have to look at the case of the PSTN, then we will look at IMS. So this is the core flow diagram between the SIP and the PSTN interworking. The PSTN is based on the SS7 and ISUB or ISDN user part. And so in the middle here, we have the ISDN user part or ISUB messages, IAM, ACM, and ANM. On the side, we have the SIP. So SIP is for the uni and SS7 is for the NNI. So the important question is that we have the caller ID authentication and also the encrypted caller ID in the SIP. How can we carry this information over the SS7 and then it can be verified again at the other end of the SIP? So the answer is Q.1912.5, and this is a relatively new standard from ITUT in 2018. So this standard specifies the message flow as we have discussed here, and is also specified the mapping from the SIP data to the ISUB message. Okay, basically it's from the invite message to the IAM message and back. Okay, so the important question is that does ITSP support Q.1912? And that's the answer we probably do not know. Okay, and from what we have seen that we do not know any top tier service provider have made any commitment to support Q1912. Okay, all the service provider, they have made a commitment to the FCC that they will support stir and shaken, but that is only on the uni side. There's no mention about the Q1912.5 to the between the top tier service providers. Okay, so that's a very important questions that we have to ask. Okay, the second approach is use IMS. So many of the publication on the stir and shaken, they will assume the IMS framework. I should also point out that IMS is not a requirement to use the stir and shaken, but by implementing IMS, it is much easier if IMS is there, it will be much easier to implement stir and shaken. Okay, so one important question is that is IMS between the service providers? is IMS deployed between the top tier service providers? That is another question we do not have the answer. Okay. So in summary, so if we back to this diagram here, so when we ask a question about whether stir and shaken is going to be effective, and there's an important question which we do not know is that whether the service provider will support a Q.1912 that will be for the PSTN interworking, or we have the IMS deployed between the top tier service providers, and we also do not know this answer. And the FCC, they have sent a letter to all the major service providers and asked for their commitment. And everyone made a commitment that they will support stir and shaken. But their commitment is only on the IP side. There's no mention about the PSTN. Okay, so that's a very important question we do not know. Okay, so in addition to the interworking between the SIP and the PSTN, we have two minor challenges, and we should also understand. And the first is about the unprotected IP-PBX. So in this case, if a hacker can compromise an enterprise IP-PBX, the hacker can use the enterprise IP-PBX to launch the robocalls. So in this case, the calls are from an enterprise environment, so all the calls will be a legitimate calls. So in this case, yeah, it will be robocall, but it will be from a legitimate source. So the service provider or the stir shaken, they will not be effective to prevent this scenario. And to protect this scenario, it will require the cooperation between the service provider and enterprise, and there will be a different mechanism that can be implemented. Okay. Another issue is about the unscrupulous ITSP, Internet Telephony Service Provider. Since the Telecom Act 96, it is relatively easy to become a CLAC. And once a service provider becomes a CLAC, they can get E164 numbers. So those are the legitimate telephone numbers. And then it will for those ITSP. And if they do not be careful in implementing stir and shaken, or their information, the attestation passed on their course are not valid, then the whole mechanism will not work. Okay. So here we can see there have been problems with unscrupulous ITSP, and FCC has been working very hard to identify those unscrupulous ITSP and make a penalty on them. But what I'm trying to say here is that it will take a lot of the effort on the FCC and also on those higher or top tier providers. And sometimes it's relatively easy for those ITSP to close down and create another CLAC. So this is like the game of a mouse and cat game. Okay, so you shut down one, they create another. You shut down another, they create another. Okay, so this will also require a very diligent effort by the service provider. Okay, so in conclusion, we have discussed about the stir and shaken, and we also mentioned that this mechanism is effective only on the IP network. If there's an interworking with the PSTN, then there's a big question whether this mechanism will be effective or not. And of course, we are looking for all IP network, end-to-end IP network, and that will require a full deployment of the IMS. And that is another big question which we do not have the answer. And I also mentioned two minor problems, and those two minor problems are relatively easy to resolve. And that concludes my talk. And thank you for your attention, and thank you for your interest.